So let's take an example that a patient has some spots on his face, and the doctor tells that 90% of the people who have smallpox have such spots on their faces. So what do we conclude now? Is he having a 90% probability that he has got smallpox? So why do we say no? Because we know that in general population, so what he is saying is that if the patient is having smallpox, then in 90% of the cases, he will have spots on his face. Okay, but he's not saying that he had smallpox. He's only saying that if the patient had smallpox, then he will have spots. Now, the question is that what is the probability that the patient has smallpox in the first place? That the doctor has not talked about. He has only said that in case you have smallpox, you will have spots on your face 90% of the time. And therefore, we should not confuse this by thinking that the patient is having a 90% chances of having a smallpox, because the doctor himself has not really talked about the patient having smallpox at all. He only says that in case you have smallpox, then there would be spots, and the chances are 90%. So now the next question to ask is that what is the probability that he will have smallpox in the first place? And that data we have available, and we see that that portion or that proportion in the population is actually very, very small, because smallpox has been eradicated from the earth long, long back. So the chances that a person will have is actually very, very less. But he also says that in 70% of the cases, even if a person had a smallpox, he will have a similar spots. Now the question is that whether he is more likely to have chickenpox or whether he is more likely to have smallpox. So that's where we also need to see that what is the chances that he had smallpox or chickenpox in the first place. And that data we can derive from seeing the number of the occurrence of smallpox or chickenpox in the population. And we find that about 10% of the people get smallpox in their life at some point or the other. But the probability that somebody will get smallpox is actually very, very small. And therefore, now we can, if we combine these two things, we can intuitively think that the chances that this person has chickenpox is actually much higher compared to the chances that this person has smallpox, because the occurrence of smallpox itself is very rare. The occurrence of chickenpox is larger, and therefore, even though the spots occur at 90% of the time when a person has a smallpox and only 70% of the time when he has chickenpox, still, when we combine the two facts, the chances that this person will have smallpox is actually much lower compared to the chances that he will have chickenpox. So now, let's again apply the Bayes theorem. As we said that intuitively, we do arrive at these conclusions in all our daily lives. But then Bayes gave us a framework where we can quantify these things. And let's revisit a similar example to understand that how the conditional probability works and how we can use it in different spheres of our life. So the first thing that we discussed was that given that a person had a smallpox, the chances that he will have spots on the faces is 90%. And given that a person had small chickenpox, the chances that he will have spots on the face is 70%. Now, in this statement, we have not even talked about that whether the person is actually having a smallpox or chickenpox or not. Okay. Now, but the problem that we are trying to solve is that I have seen a symptom, and that symptom is the spots on the face. Given that symptom, can we find out what is the actual cause? Is that cause a smallpox or is that cause a chickenpox? So the problem that we need to resolve, or problem that we are really concerned with, is this one. That is, what is the probability that the person is having a smallpox, given that he had spots on his face, and the person has a chickenpox, given that he had spots on his face. This is the real problem we are trying to resolve. The first one can give us some indication, but that's not the answer. So again, we will apply the Bayes principle. And if you recall, what we had discussed is that the probability of A, given that we know B, is equal to probability of A multiplied by probability of B, given that we know A, and divide that by probability of B. Now this one, you must remember it. You must put this to your memory, because I will repeat that this is one of the most important things that we'll come across when we solve the real life problems using the machine learning principles. Now, if we say A for smallpox and B for the spots on the face, and we'll take two different computations, each for smallpox and chickenpox. Again, we apply the same thing. So what's the PA here? So PA is nothing but the probability that a person is having a smallpox, and that is given here. And the probability of given the chickenpox is given here. Now again, just we apply the Bayes theorem, and we find that the probability that a person will have smallpox is actually only 0.3%, whereas the probability that a person will have smallpox is actually 23%.